You probably assume human brains have been getting bigger this whole time, steadily climbing towards some evolutionary peak, smarter with every generation. That's backwards. The average human brain today is smaller than it was 10,000, even 20,000 years ago, by a meaningful margin, roughly the volume of a tennis ball. Not a rounding error, not a measurement fluke across a handful of skulls. A consistent, well-documented shrinkage across multiple continents, multiple populations, happening at exactly the moment our species was supposedly getting more sophisticated, building cities, inventing writing, and developing agriculture. If bigger brains meant smarter, more capable humans, this is the opposite of what should have happened. And figuring out why it happened anyway might tell you more about what intelligence actually is than any IQ test ever could. Today, when you think about brain size, you probably associate it loosely with intelligence, more brain, more capability. In the same rough way, a bigger engine means more horsepower. It's an intuitive assumption, and for most of the 20th century, plenty of scientists assumed the same thing. But the fossil and skeletal record doesn't cooperate with that story at all. Cro-Magnon humans, our direct ancestors living in Europe around 20,000 to 30,000 years ago, had average cranial capacities estimated at around 1,500 cubic centimeters, sometimes higher. The average human brain today sits closer to 1,350 cubic centimeters. That's a drop of roughly 10 to 12%, and it's not a fringe finding. It shows up consistently across skeletal collections from Europe, Africa, and Asia, spanning the transition from the Upper Paleolithic through into the modern era. Here's the thing that makes this genuinely strange rather than just interesting. This shrinkage lines up almost exactly with one of the biggest technological transitions in human history, the shift to agriculture, starting roughly 10,000 to 12,000 years ago depending on the region. That timing has led to one of the most debated questions in paleoanthropology, and there are several competing explanations. None of them fully settled, all of them worth taking seriously. The first, and probably most straightforward, explanation is body size. Brain size doesn't exist in isolation. It correlates fairly strongly with overall body mass across mammals, humans included. And there's solid evidence that human body size decreased somewhat during the same window, particularly following the shift to agriculture. Hunter-gatherer populations before agriculture generally show taller stature and more robust skeletons than early farming populations. Agricultural diets, heavily dependent on a narrow range of cultivated grains rather than the wider, more nutrient-dense range of wild foods hunter-gatherers ate, appear to have come with real nutritional costs, at least initially. Skeletal analyses of early farming populations across the Near East and Europe show increased evidence of nutritional stress, shorter average height, and more dental problems compared to the hunter-gatherer populations that came before them. If bodies got smaller, a brain shrinking somewhat proportionally isn't shocking on its own. But here's the problem with stopping the explanation there. The brain shrinkage appears to be somewhat disproportionate to the body size change, larger than body size correlation alone would predict, which means something else is very likely going on as well. Now here's where it gets genuinely interesting, because one of the more compelling explanations doesn't come from nutrition at all. It comes from an unexpected place: domesticated animals. Researchers, including anthropologist Brian Hare, have pointed out something striking when you compare domesticated species to their wild ancestors across the board. Domesticated dogs have smaller brains relative to body size than wolves. Domesticated sheep have smaller brains than wild mouflon. Domesticated pigs have smaller brains than wild boar. This pattern shows up again and again across nearly every species humans have domesticated, and it's tied to something researchers call domestication syndrome, a cluster of physical traits, including reduced brain size, that reliably appears when a species is selected, intentionally or not, for reduced aggression and increased tolerance of crowded, socially complex environments. And that's the part that should make you sit up. Some researchers have proposed, somewhat provocatively, that humans may have effectively domesticated ourselves over the last several thousand years, particularly as we shifted from small, mobile, hunter-gatherer bands into large, dense, settled agricultural communities. Living in permanent settlements with hundreds or thousands of other people requires a completely different behavioral toolkit than living in a mobile band of 20 to 50 people you've known your whole life. Higher tolerance for strangers, more conflict avoidance, more willingness to defer to social norms and authority rather than resolve every dispute through direct physical confrontation. In evolutionary terms, individuals who were less impulsively aggressive, more socially cooperative, and better able to tolerate the stress of dense, crowded living may have had a survival and reproductive advantage in these new agricultural societies, in the same broad way that calmer, less reactive wolves had an advantage as they gradually became dogs living alongside human settlements. If that selection pressure operated on humans, even partially, a modest reduction in brain size, following the same domestication pattern seen in nearly every other domesticated species, wouldn't be surprising. It would be expected. But here's a critical point that keeps this from being a neat, tidy story. Brain size and intelligence are far less tightly linked than most people assume, and this is really the crux of why the shrinkage doesn't mean what your first instinct probably tells you it means. Neanderthals, for context, had brains that were on average slightly larger than modern human brains, and nobody seriously argues Neanderthals were more intelligent than Homo sapiens in some simple overall sense. What seems to matter far more than raw volume is internal organization, connectivity between regions, and efficiency, how much processing power the brain gets out of the energy and space it has, rather than simply how much space it occupies. And this is where a competing, and in many ways more compelling explanation enters the picture. Efficiency through specialization and externalized knowledge. Here's an idea that reframes the entire question. In a small hunter-gatherer band of 25 people, every single individual needs to personally know an enormous range of survival information. How to track dozens of species of animals, which of hundreds of plants are edible or poisonous, how to make fire, how to build shelter, how to navigate by stars or landmarks, how to treat injuries, how to read weather patterns. That's an immense cognitive burden carried individually by every member of the group because there's no specialist to rely on. Everyone is, to some extent, a generalist expert in dozens of overlapping survival domains simultaneously. Agricultural and later urban societies fundamentally broke that model. Once you have a farmer, a toolmaker, a builder, and eventually scribes, merchants, and priests, no single person needs to hold the entire survival knowledge base in their own head anymore. Knowledge became distributed across a society rather than duplicated individually within every brain in it. Some researchers argue this externalization of knowledge, first through specialization of labor and later dramatically accelerated by writing itself, may have reduced the raw cognitive load, and by extension, the brain volume required of any single individual to survive and reproduce successfully. In this view, shrinking brains aren't a sign of declining intelligence. They're a sign of a species that figured out how to outsource cognition to the group itself, to social structure, to written language, to specialized roles, rather than requiring every single brain to carry the full weight alone. There's actually a striking piece of supporting evidence for this efficiency argument, and it comes from a place you wouldn't expect: neuron density and metabolic cost. The human brain, despite being only about 2% of total body weight, consumes roughly 20% of the body's total energy at rest, an extraordinarily expensive organ to maintain. Every cubic centimeter of brain tissue carries a real metabolic cost, calories that have to be found, hunted, gathered, or grown, and consumed day after day just to keep that tissue alive and functioning. In a world where specialized roles and shared knowledge reduce the need for every individual to independently store and process an enormous, redundant survival database, a slightly smaller, more efficiently organized brain wouldn't be a disadvantage. It might actually represent a genuine energetic advantage, freeing up calories for reproduction and other survival needs, while relying on the collective intelligence of the group. Plus later, external memory systems like writing, to handle what individual brains no longer needed to carry alone. This connects to something anthropologists sometimes call the extended cognition or cognitive offloading idea, though usually applied to modern technology like smartphones and calculators. But the underlying principle is much older than smartphones. The moment humans started reliably writing things down, roughly 5,000 years ago in Mesopotamia with early cuneiform, they created the first large-scale external memory system in history, a place to store information outside of any single human skull. Before writing, an enormous amount of critical knowledge, genealogies, laws, agricultural timing, religious and practical knowledge had to be memorized and mentally maintained by specific individuals within a community, often at real cognitive cost. Once you could write it down, that specific type of memory burden began shifting outward onto clay tablets, then papyrus, then paper, and eventually screens. A process of externalizing cognition that has arguably been accelerating, not slowing down ever since. None of this means modern humans are less capable than our Paleolithic ancestors in any simple sense. If anything, the evidence increasingly points the other direction. What changed wasn't raw processing capacity so much as what that capacity gets used for and how it's organized, both within individual brains and across entire societies functioning as extended cognitive systems. A hunter-gatherer 20,000 years ago needed to independently hold a staggering amount of practical survival knowledge in working memory at all times, with genuinely zero external backup beyond other people's memories. You, right now reading this, are relying on an almost unimaginably vast external knowledge system. Cumulative human knowledge stored across libraries, databases, and networks that no single brain in human history has ever had to carry alone. And that fact alone may say more about the actual trajectory of human intelligence than a decrease in cranial volume ever could. So why did human brains shrink over the last 10,000 years? The honest answer is that researchers are still actively debating the exact weighting between these explanations, and it's likely not just one cause, but several compounding factors working together. Somewhat smaller body size tied to early agricultural nutrition, a domestication-like selection pressure favoring calmer, more socially cooperative individuals suited to dense, settled life, and a genuine efficiency gain from a species that learned to distribute knowledge across specialized roles and, eventually, written language, rather than requiring every individual brain to independently store the entire survival playbook. So the next time you picture human evolution as one long, steady climb toward bigger and better, remember that the actual data points in a stranger, more interesting direction entirely. Our brains have been getting smaller for 10,000 years. During the exact period we built cities, invented writing, and became more capable as a species than at any other point in our history, which means the real story was never really about the size of any individual skull at all. It was always about what all of those skulls, connected together across an entire society, could do that no single mind, no matter how large, ever could on its own.